All right. Here is lesson 17's homework assignment. So the remainder theorem. The remainder theorem allows us to quickly figure out what the remainder of a function is just by plugging in a number. Also, we can go through and do some division and figure out what the remainder is as well. So kind of now we have two methods of doing this. The remainder theorem does help us quickly get to a remainder, which sometimes can help us do some questions more efficiently or quicker. So let's take a look at number one. Number one gives us f of x. And it says divide f by x minus 3. So let's do some division here. I'll do this one using the tabular method. So we'll put x cubed in the first box. I know that's going to generate x squared. This tells us I have 3 columns. If that's x squared, this is negative 3x squared. Well, these two have to add up to negative 6x squared. So I got to make that negative 3x squared, which makes us negative 3x. Well, if that's negative 3x, I know this is positive 9x. Well, I want negative 7x. So what do I have to add to 9 to make negative 7? Well, since I have to work backwards, I have to subtract. So I know this is obviously going to be a negative number. And if I do, what's that going to be? 16x. So that's negative 16, and this becomes 48. Now, the tabular method can be a little bit confusing for what the remainder is going to be. Remember, it's what do you have to add to 48 to make 9? So it's saying like 48 plus what makes 9? Well, that's going to be us working backwards again, so it's going to be subtraction. So the answer to this is going to be x squared minus 3x minus 16 minus the remainder divided by x minus 3. And the remainder is going to be 39. Now, if I go through and find the value of f of 3 using the remainder theorem, I'm going to do 3 cubed minus 6 times 3 squared minus 7 times 3 plus 9. Well, notice that also comes out to be negative 39. Kind of like a check. Now let's look at 2. 2 gives us the remainder theorem again, and it says, is this a factor? Now, it's not going to say use the remainder theorem, but this is a remainder theorem question. So if I want to determine if this is a factor or not, I'm just going to plug in negative 1. So I'm going to say 2 times negative 1 to the 5th minus 4 times negative 1 to the 4th plus 9 times negative 1, etc. And if this comes out to be 0, then it's a factor. If this doesn't come out to be 0, well, then it's not a factor. So this is going to become negative 2 minus 4 minus 9 plus 1 plus 13. So we wind up having negative 6, negative 15, 14. Well, that comes out to be negative 1. Therefore, this is not a factor. All right, number 3 is another question that is a remainder theorem question. I don't really need to do long division 4 times here. That would be crazy, right? All I have to do is plug in an x value of 1, 2, 3, and 4 and see which one has a value of 0, right? So if I plug in 1, I'm going to get 1 plus 3 minus 10 minus 24. Well, that's going to wind up giving us negative 34, negative 30. So that's not the answer. If I plug in 2, that's going to give me 8 plus 12 minus 20 minus 24. Well, that's going to give me negative 44 plus 20. So that's going to be negative 24. Not my answer. If I plug in 3, that's going to give me 27 plus 27 minus 30 minus 24. Well, that gives me 54 minus 54, 0. That's what I want. So that's my answer. The last question says, with this function f, it's a polynomial. It gives us some values for x and f of x, so essentially the coordinates of the points on the graph. And it says, what is the remainder of f when divided by x plus 2? Well, x plus 2, well, that's where we're going to look at an x value of negative 2. So I know if f of x is divided by x plus 2, the remainder is negative 42. I know all of that just from that one point. I don't need anything else there. And the reason why is because of the remainder theorem. So the remainder theorem says whatever number makes this binomial 0, well, that number when plugged into the equation generates the remainder. So instead of plugging it into an equation, I'm just finding it on the table. It's the same idea. Also from this, I could even find out more information. I know that it doesn't ask you to do this, but like I know this is a 0. So I know this would have a remainder of 0. So x minus 2 would be a factor of f of x, right? Where x plus 2 is not a factor, right? Because it has a remainder of negative 42. Hopefully this video helps. Remember, you have a quiz tomorrow on lessons 11 through 14. Good luck studying.